Next, we have Jonathan Rosenberg. He is the CTO and head of artificial intelligence at Five9. He is a co-inventor of the SIP standard. He shipped many of the industry's first products, the first SIP stack, the first SIP proxy, and the first session border controller. He was the principal behind WebEx Teams and the chief technology strategist for Skype. He says that we are in the midst of a migration from IP PBX and contact center and meeting technologies to software as a service delivery models. Title of his talk is What Does the Cloud Mean for the Future of Telecom Technologies? Let's give a big ClueCon round of applause to Jonathan Rosenberg.
All righty, thank you everybody. I'm really excited to be here. Lots of interesting stuff happening in our industry and space, and I'm sort of excited to share with you my thoughts on where things are going around SIP and SIP trunking. And Anthony's actually sort of alluded to some of what I'm going to be talking about this morning, so should be pretty cool. So just a little, again, you heard I'm the CTO for Five9. Just my little plug, Five9 is a cloud contact center provider, one of the leaders in this space. Our voice stuff is based on FreeSwitch, so we're part of the community. We're one of the companies that Anthony showed sort of using and getting value out of the product, and so we're here to participate in the community. So, as you heard, I'm Mr. SIP. I wrote the Sip Spec with a bunch of other folks, and been working on those standards that Anthony says nobody can implement and are a really big pain. I'm sorry about that. I did a thing recently, a little exercise, by the way. I said, how big is the Sip Spec? And I went, and actually took me a long time. I collected all the page lengths of all the published SIP RFCs and figured out how many pages is it and how many hours would it take you to read this, what is now monstrosity, by the way. And I forget the exact number. It's something like 7,000 pages of documentation that if you to read nonstop would take you over 40 hours to read. So yes, I can understand why you might not be able to make it all work. But it's had some good success in the marketplace, and things are changing again. So that's what I want to talk to you about. What is the future of this technology and of its biggest use case, which is SIP trunking? So there's really, in my view, there's basically been 3 eras of telecom. And Anthony outlined sort of a similar story, I think. And it started with hardware, which is back in the old days where you had a physical box with T1 line cards and whatever. And then it went to software. In the enterprise space, Cisco was the big disruptor there, Skype in the consumer space. And this was sort of the era of the soft PBX, the soft switch, free switch, and asterisk, and other technologies. And what we're seeing now is the next wave, where it's cloud and SaaS-based models for delivery of these telecommunications capabilities. And in the enterprise space, which is where I'm going to pretty much focus this whole time, a new set of companies is sprouting up here too, right? If you want to know who's the number 1 leader in cloud telephony, it's not Verizon, it's RingCentral. All right, that's kind of interesting. So we get a bunch of new companies in this space. Five9, we're one of them. Vonage, I saw Matt was somewhere. We got Vonage, there he is. Vonage, there's people playing in this space. It's a new set of characters. So, and as we're transitioning this to the cloud, what we're in the middle now is sort of almost going over the top of the adoption curve. So, and actually, if you break up our collaboration business into different segments, you actually sort of see something really interesting, which is some of them are fully cloud-based. So team collaboration, a la Slack, WebEx Teams that I worked on, Microsoft Teams, those all started in the cloud, and they're 100% cloud-based. Similarly, CPaaS, a la Twilio, maybe I shouldn't say that word here, the T word, but they're born in the cloud, software as a service company. And then if you take the classic telecom services, meetings, UC a la telephone calls, and CC a la contact center, they're at different phases of migrating from the premise software model to the cloud model. Meetings is farthest along. It was already a couple of years ago where we had more than half of new seat sales for meetings were cloud-based. UC is getting there, and contact center, interestingly, which is where I work now, is only 10% penetrated for cloud. So we're sort of hitting this tipping point as everyone makes this transition over to the cloud side. And so this raises an important question. SIP was a technology born of the prior era. And a lot has changed. So what is this transformation to cloud for UC meetings and contact center? What is that going to mean for SIP networks and for SIP technology? So the first thing, and I'll talk a lot about SIP trunking, right, which is a lot of what you do with FreeSwitch. You plug it into SIP trunk providers. That's going to change a lot. And what happens today is you got a bunch of companies, and they buy some kind of PBX software, whether it's using FreeSwitch itself as a PBX, and they install and run it, or they got a Cisco or an Avaya or whatever, one of those guys, they install it on their data center, and they connect a SIP trunk out to a SIP trunk provider. And pretty much every telco on the planet will offer enterprise SIP trunking services today. It's a massive market and growing. That's what it looked like in the era of software. In the cloud era, it looks a lot different. In the cloud era, each enterprise individually is not connecting to the phone network. They buy telephony services from a contact center provider or from a UC telephony provider. And those guys go and they connect to the cloud. The enterprise's connection is through the internet or a private IP network, is to the contact center or the meetings or the UC telephony provider. So the SIP trunk moves to the cloud. The SIP trunk moves to the cloud, right? And when you think about that for a second, it has lots of implications. The biggest one is this one, which is a massive cardinality reduction. So today, if you think about it, I'm sure there's some business guy or marketing guy who went down and said, how big is the SIP trunking market? And they did some math and they said, well, how many enterprises are there in the world? And every one of those is going to probably need a SIP trunk, just like they needed a T1 before it. And so there's hundreds of thousands of them, and each of them are going to buy blah, blah, number of ports, and so on and so forth. In the cloud model, it's not the enterprises who buy the SIP trunk anymore. It's the UC provider or the contact center provider, right? They're buying these SIP trunks en masse. There aren't hundreds of thousands of these. There's not even thousands of these. There might be hundreds of these, but there's only a dozen or so that probably matter in terms of the percentage of traffic. So what we have is an enormous multi-order of magnitude cardinality reduction in the number of customers over time. This doesn't happen overnight. This is a transition, what happens over the next few years kind of thing. As we shift from on-premise PBXs to cloud, the number of people buying SIP trunk services will decline to a smaller number, right? So that's really fascinating. That has some interesting implications, right? Which is the volume also consolidates. So today, each enterprise buys a SIP trunk to the cloud, and they each, make however many calls they make, and 100 calls a day, 1,000 calls a day, or whatever. The cloud providers, right? They aggregate across many customers, and they share that trunk across all of their customers. And that's the whole fundamental idea of a multi-tenant cloud solution. So you have a much smaller number of companies, but they generate way more volume of traffic. Now that's interesting too. And if you added up the little bars on the left, they should roughly be equal to the two big bars on the right there. Maybe we'll see more or less calling, but the total volume doesn't change, which changes how we've broken it up. So that has a really interesting economic implication. When you buy lots and lots of volume of stuff, you get discounts. You have pricing power. Right? I mean, if you're Five9 or if you're Vonage and you go to your telco and you say, I'm out, I'm leaving your Verizon, I'm going to AT&T, and I generate 8 billion minutes a month or whatever, they'll be they're going to come and kiss you behind to keep your business, right? So you can drive the cost down, and so that means the economics dramatically shift. And in fact, as these guys scale up, it starts to become more cost effective just actually to directly peer with each other. It's sort of something interesting that I think will happen in the future is hey, I'm Five9, he's Vonage, why don't we just, we're enemies in the market, but let's peer. We both save money. And then we don't have to pay the middleman. That starts to be even feasible, but it's infeasible when you have 100,000 enterprise. It's very possible when you have 12 cloud vendors that matter. So everything's going to shift in this thing on the business side. So that's fascinating, right, is the price erosion. And then it's going to also change the nature of what the service is. So today when you buy SIP trunking from an enterprise, from a carrier as an enterprise guy, you worry about things like, what does my admin portal look like, and do I have flexibility to configure parameters of the trunk, and what's the value add that the service provider provides to the enterprise, and the add-ons that they can sell. Classic enterprise business. As this stuff moves to cloud companies that purchase these services, right, they start to care about different things that matter more when it becomes a commodity service you're trying to scale up for operational cost. Now what matters is API access. I'm not one little enterprise. I'm adding like a dozen enterprises a day, 50 enterprises a day. I need API access to auto provision this stuff, right? I don't want to sit in front of an admin portal. It needs to be simple, right? So that I can make it work in my automation environment. I need to worry about cost optimization of this stuff. So the value propositions change because the buyers change, because the volume has changed, the cardinality has changed, the product is going to change. So SIP trunking is going to evolve dramatically. And if you look at the enterprise still needs connectivity, but its connectivity isn't SIP peering anymore, it's IP peering. Because now the traffic from the enterprise on the left in the software era, that was SIP to the telco, right? And now they've got phones in there, but no PBX, so phones sit in the campus. Or maybe they're not even on the campus, maybe they're at homes or whatever. They need to connect to the UC or meetings or contact center provider, and that's going to be lots of proprietary stuff on the phone to server link that's specific to each vendor. There's probably maybe some SIP in there, but maybe not. If it's WebRTC, as Anthony said, there's no SIP. I'm happy to talk about why we made that decision. It'll be you care about IP connectivity, so it totally changes what enterprises buy. Now they buy like mass volume wholesale IP interconnectivity to lots of SaaS providers. And of course, there's a market for those now. So Equinix is one of the more well-known ones. You basically peer once to Equinix, and then they can, like one click, and they'll connect you to any of a large number of SaaS providers that they connect to. So that's like the replacement for SIP trunking for the enterprise. It's like IP peering, just totally different. There is going to still be some private SIP trunking for a while. Make no mistake, these transitions take a while. Many customers, I think, enterprises are going to do this thing, which is sort of hybrid. And the idea is that you're a big enterprise. The big guys will all do this. Little guys will probably just port their numbers. But the big guys already bought tons of SIP trunks from providers all over the world, and they set them up, and they have a worldwide global telephony network that Cisco or whatever helped them deploy. They may want to put their PBX in the cloud, but they've negotiated these fantastic contracts with Verizon or AT&T, and they're not going to give them up. So they just want to keep the trunk, but move the PBX. And so that's this model here, where the cloud service has a SIP trunk, but it doesn't go to a telco. It goes back to the premise, which effectively acts as its own little SIP peering provider. So we're going to see a bunch of that, and that's another type of SIP trunk that's out there today. So this isn't science fiction, actually. When I was at Cisco, we built this with WebEx, super popular, and there are other vendors doing it too. So Zoom is another vendor that has this product as well. So and my expectation is that more and more telephony-centric cloud providers will provide these type of private SIP peerings for the larger side of the enterprise market. So there's even more ripple effects of this thing as I start to think about it. So what does it mean for the SBC market? I hope there's probably some SBC vendors out there. This slide sometimes elicits unhappy responses, but it's going to grow for a while as we continue to move more and more to VoIP. I mean, don't forget, we still have tons of analog and digital trunks out there. As those guys gradually move to software, as we see more hybrid deployments, we'll actually see a growth in SIP trunking, and the market is growing right now. But as we start to hit the turnover point where it's more cloud than it is premise, you will start to see the decline as people retire their SIP trunks because they no longer need them. And when that happens, the SBC market, which is really two segments today, the carrier and the enterprise side, the enterprise SBC market will start to tank. That's not like next year or even the year after that. That'd be like 4 to 5 or more years out, but that's sort of where I think it's going to go. And in the cloud providers, what will happen as they scale, almost always what happens is you start to build your own technology because it's better integrated into your overall operational, automation, functional pipelines. And so I suspect what we'll start to see is a decline in the usage of totally commercial off-the-shelf third-party SBCs that are deployed by these guys, and a movement towards taking technologies like FreeSwitch and building them and customizing them and doing some coding to integrate them into their environment. So I actually think this is a very interesting opportunity for FreeSwitch technology to grow as we scale up this transition. So similarly, the carrier market is itself, and I'd split carriers from the as-a-service vendors I just talked about, who I think will over time want to build their own, and the traditional telcos. The traditional telcos historically do not write their own software. So they're going to continue to buy SBCs en masse. They'll need more and more of them to terminate towards the small number of cloud providers. So the carrier market will probably grow, but the enterprise market will diminish. So that's sort of the interesting transition. This leads me to the thing I'm most excited to talk to you about, which is if you sort of play that all forward, you start to realize that things are really, really changing. And this SIP technology that we've had for a long time, the SIP RFC, originally RFC 2543, was published, my friends, in 1999. 1999, that's when it's published. Work on it started. This was like my PhD thesis topic ages ago in 1996. Okay, 1996 is 23 years ago. There was no smartphone. There was, we didn't have iPhones. We didn't have cloud. There was no AWS. There was no Docker. There was no virtualization. There were no VMs. The internet didn't even look like it does today. When we started working on SIP, there weren't NATs. Okay, that's why anyone ever wonder why SIP sucks so bad at going through NAT? There weren't really NATs when we started it. We added it on via ICE as a later add-on. So this technology, it's old, and a lot of the world has changed, and it's going more and more to cloud. So in a cloud delivery model, what does a new technology look like for delivering telephony? And this is a new technology, really brand new. We wrote this document. It's the first version of the spec. It's not an official working document of the IETF. There was a lot of interest in it. We got a lot of co-authors who contributed and a lot of interest at the IETF meeting. So early days, so you're seeing a snapshot into where I hope this technology goes in the next 1 to 2 years with RIP, the Real-Time Internet Peering Protocol. So what is it trying to solve for? It's trying to solve this. How do we do next-gen peering between a cloud provider, a UC provider like Vonage, a contact center provider like Five9, a meetings provider like WebEx, the big cloud guys that I said there's going to be just a few dozen of them. How do they trunk over to Comcast? And not just them, enterprises too. So if you're an enterprise and you're not in the cloud, but you've got an on-prem FreeSwitch or any other PBX, what's the next generation technology you're going to want to use to connect out to a trunking service? In general, how do we connect to data centers or clouds or service providers together to peer at the SIP and telco and telephony layer? Not so much focused on the client to server, not really replacing the classic digital interconnection that the carriers have, which is now all SIP based and unlikely to change again. This is really on the other side of that. So that's the problem space for RIP. And the problem we're trying to solve, why don't we just use what we already have something here at SIP. What's wrong, besides that it's old, what's wrong with SIP? Well, the problem is the cloud. That we're now seeing more and more software deployed in these environments that are built around one core fundamental technology that is the heart and soul of all that is the cloud, everywhere, Amazon, Microsoft, Google. It is based on this one core technology. What is it? HTTP. Not SIP. And so if you want to deploy a piece of technology in the cloud using, Kubernetes, and everyone try and deploy telephony on Kubernetes, FreeSwitch, Asterisk, it all sucks. It's really hard because the networking doesn't follow the classic HTTP paradigm. Anyone ever try and make this stuff work on Istio? Good luck with that. It only works with HTTP. Anyone ever try and make SIP work with Amazon's global HTTP load balancer? You can't do that either because it's not HTTP. So more and more, the entire way you build modern software, this cloud microservices with HTTP front ends, global load balancers, all this tooling is built on HTTP. HTTP is the foundation of the modern internet. Okay? And so as a result, there's all this technology now out there. Like if you were going to build software from scratch, like you go build it on Amazon, and all of a sudden, like pretty much for free, you have like global HTTP load balancing with like Anycast DNS capabilities and global geo-redundancy and automatic auto-scaling up and down of all your server instances. That stuff's pretty cool, right? You don't have to do that work anymore. You do if you build telecom services. So the problem is that this technology has not kept, SIP technology has not kept up with the innovations that we've seen in modern web-based platform as a service environments. And we don't want to redo that work over and over, okay? So that's the problem we're trying to solve, is how do we take this telco technology and make it work out of the box in cloud environments? And in a lot of ways, this is basically solving, as a result, the other half of WebRTC. WebRTC was about how do we bring audio and video from the browser to the web app, but once you got to the web server, good luck if you wanted to connect to the PSTN. Like, it worked fine if there was no trunking backend. Right, so if you were building a meetings product or whatever, this was easy. But if you wanted to go to the PSTN, oh my gosh, now you got to deploy a free switch, an SBC, you have to set up special firewall rules, you need to hire an army of telco engineers and figure this stuff out. Like, but if you wanted to invoke a REST API call to some downstream service, like that's easy peasy these days in the cloud. You don't even think about it. So we haven't solved that back leg. That's what RIP is for. So there's some interesting use cases. One of the ones that's of particular interest to me as a contact center provider is how do we bring voice to the web to the contact center? Now, WebRTC brought voice to the web, but you couldn't get it out from the web to go somewhere else. So if I'm a little business and I'm a restaurant and I have a little website, today I can go to my website and I can click to chat with an agent. I can click to, email the agent. You want to call an agent? You're lucky you can put in a request for a queue callback. Most of the time, you just read the phone number and you type it in your mobile phone. Wouldn't it be great if I could use these awesome audio codecs like Opus and to get a high-quality wideband connection right from the browser all the way to the contact center, who is probably a contact center as a service provider like us? That's a trunking problem. And right now, that goes to the PSTN and SIP, and it's hard, and that's why you don't find that at most websites. Wouldn't it be cool if this was like, you go to Shopify and you do the one-click add a voice contact center agent to my website, one button, and you don't even think about it anymore. You just OAuth into your contact center provider and you're done. That would be so cool, right? How do we build telecom apps on web paths? And I talked about this using load balancers and Kubernetes and Istio and APM tools and all these things that are built for the web world, right? How do we build a next generation of enterprise voice trunking, right? It's still the case that if you want to have a soft switch and a free switch on your enterprise premise, it's still a lot of work to get that thing to connect out to through the firewall. And raise your hand if you've ever struggled with SIP and VoIP configuration through firewalls, please. Raise your hand, right? A few of you haven't raised your hand. Have you never tried it? I mean, it's a huge pain, right? So, and not just the firewall stuff, but provisioning. Oh my gosh, like good luck with that. Like it takes like 3 months to provision a SIP trunk with your telco. How long does it take to provision a REST API onto a cloud service provider you purchase a service from? No time. You go to you OAuth into it, and 2 seconds later you're done. Why can't we have it the same with telco? Why can't telco be as good as all these web apps? This is a thing that's been gnawing at me, right? So we decided I said, let's fix that. Like, create a new technology that makes it as easy. And how do we solve some of the reliability problems that still continue to make VoIP hard? SIP has some stuff that you can use to deal with things like cluster expansion and contraction, server restarts and retries. Like if you run a PBX on a VM, the underlying provider will often do a VM restart or VM migration under the hood, and you could drop calls. So how do we build a system that out of the gate, maybe you'll have a moment's gap in voice while you have a restart, but the technology's out of the gate built on the assumption that the server's going to die all the time. And it's just built-in support for that. So how do we get reliability? So that's what RIP is. RIP is literally a new protocol meant to replace SIP and SDP and RTP just for this use case. It does not replace all of what SIP does. Those 4,000 pages, this doesn't scratch the surface. This doesn't replace IMS. This doesn't replace the usage of SIP from a cell phone to a carrier network or all these kind of other things. But for this one use case, focused on voice, peering between a cloud provider and a telco, it replaces it. I'm almost out of time, so I'm going to have to sort of go quickly through this part. And the trick is HTTP 3. HTTP 3 not yet really deployed yet. It's just starting. It's the next generation of HTTP, and it made one really important technical change that changed everything. And that technical change is it runs on top of UDP, not TCP, using a new transport protocol called QUIC, which is not TCP. It runs on UDP, and it can be used to provide unreliable transport over which you can carry media packets. That's the big change. So under the assumption that HTTP 3 will eventually get deployed everywhere, because that's how things go, let's build a thing that it's just a web app on top of HTTP 3. That's it. And it just built in a way that takes advantage of HTTP 3's capabilities. So that's what it is. Just works with any HTTP 3 web infrastructure. I don't want to have to call Google and say, do you support RIP technology? They don't have to know what RIP is. I don't want them to know what it is. I want them so that their load balancer, their HTTP load balancer, it just works for RIP because RIP is just a web app. That's it. Voice peering is web. It's easy to gateway to SIP because we're going to have a ton of that still. It's always encrypted and authenticated. There is no insecure operation. And to deal with another problem that gnaws at my soul, I promise you, is there is no insecure caller ID allowed. It must use the modern secure caller ID technologies. This thing called STIR is built in and mandatory. One-click provisioning built in. OAuth authentication and authorization. Easy to add to an SBC and a soft switch. Graceful call migrations from server to server. And I can't even read it. Rapid failure detection in a couple seconds, all built into the protocol. So I'll probably just stop here after I go through this and explain just a little more. It looks like a web app. So if like Five9 wants to connect to Comcast as a provider, it would start with OAuth. Like someone at Five9 would have bought trunking service from Comcast. Now that they've bought it, there's like, they go and sit down. We sit down at Five9's administrative console. We select Comcast. We get a little thing from Comcast. Five9 is requesting access to your account. Do you approve their ability to create calls, create trunks, delete calls? Yes. Click that, and then we're done. That's it. The rest of this is automated. It automatically creates, using a web API, a trunk. It automatically does a capabilities exchange in both directions. And then we're ready to create calls. So you make a call, and after that, it won't be able to go into it. It creates these things called byways, which are sort of the somewhat hokey way we get RTP or media traffic to run over HTTP. And we exchange events and call signaling, and we're good. And it's all fully automated up to the point where we make a call. So that's pretty much the story. We have REST APIs. It looks like a classical web app. I'll skip over this. And it's secure by default. So it requires HTTPS, which runs over TLS. It uses OAuth for client authentication. Today, if you want SIP trunking, most people do that on a private network, or they use mutual TLS. Good luck setting that up and exchanging certificates, fingerprints and stuff. It's horrible. Everyone does server authentication to client with certs using a public cert chain, client to server using OAuth in a separate login screen. That's what we're doing. And end-to-end security actually is not there because we're going to the PSTN. So that's it, and I'm excited about this tech. I'm actually working with Anthony on it. He's one of the co-authors of this document, along with colleagues from Google and a few others, Comcast. And I think this is exciting for FreeSwitch. In my view, RIP frees FreeSwitch from the baggage of the past and rips it to the tech of the future. That's the tagline. So that's it. I think we've got maybe a couple minutes for questions. There are probably some.
Big round of applause for Jonathan Rosenberg. Do we have any questions for him?
All right. That's surprising. Yes. Yeah. Question was, will I provide the Prezzo? Yeah, absolutely. Also, I may not be in the deck, but I'll just add it in. There's a URL for the spec. It's like a 30-page IETF draft that you can go read with the details. Work in progress, by the way. It's totally unimplementable, but you know, it's the first. But it's just like there's no syntax to find. So I mean, like we'll get to that. It's not ready for that yet, but I'll send around the link. Yes. That's right. Yeah, so the question is, how is the media transported over this new protocol? It's not going to be RTP. No, the way to think about it at the application layer, the simple version is each RTP packet will sort of look like a long-running HTTP poll. So I'll do an HTTP long poll, and what comes back is just a never-ending series of data. And the way the protocol is structured, because the underlying transport is UDP, you don't have any header line blocking, you're not waiting, but it basically looks like an HTTP long poll. Okay, other questions?
When do you think this will be ready to be implemented?
Yeah, so the question is, when is it going to be ready to be implemented? Well, the goal is to start implementing pretty soon. So actually, if they're to test it. Like the goal is not for this to be a theoretical spec exercise. Like, you know, the original Sip Spec went with the code. Like I was coding that thing as we were writing the spec. At some point, years and years later, it got way out of hand and tons of documents were written without software. I'm not doing that with this. So this is going to be built with software at the same time to prove it out. So the goal is to implement it. Ideally, we would do it in FreeSwitch like soon, like a month from now, or whatever, and see if it works. And if it works, bring a new document to the IETF with like, hey, we implemented it and it works. And by having a Google guy and a Comcast guy on board, we basically have all the pieces together to actually do a cool demo. I'd love to do that. The first RIP call from a phone to FreeSwitch to a contact center to the PSTN. That would be freaking awesome.
Wonderful. All right, big round of applause for Jonathan for his great talk
All right,
and for all of his great work on the SIP standards.